By now, you have a sense of how familiar nickel is to a SQL developer. What is different is the data model. You are querying JSON documents with no enforced schema. Now in this lesson, we'll learn how to filter for missing fields and values, as well as extend the prior lesson a bit to look at how to group and filter grouped results. Now, enforcing a strict data schema on every write operation makes sense for traditional systems of record where long-term schematic stability is worth the slow development cycles and long-term rigidity involved. Now, Couchbase focuses on agility and scalability instead. JSON documents can evolve however needed to support rapidly evolving software focused on innovative systems of engagement. So in a nickel query, any given field may have a value, or it may be physically present yet have no value. A field may physically exist or be missing, and a field may be explicitly null or not. Your data model can evolve however your object models require, and you can query as needed to analyze your evolving document structures. The missing, null, and valued keywords operate as filters. Testing for missing fields gives insight into the evolving structure of your documents. Testing for nulls can be done for the inherent meaning of such fields. And testing for whether fields are valued can provide insight where documents are generated based on a desired structure and then later populated. Relatedly, in JSON, nulls are normally encoded using the null keyword, as you might expect. On a separate note, it's commonly useful to group query results. For example, to calculate perhaps results by country or state or the like, some kind of division element. So it should be no surprise at this point that nickel provides the same capability using the same syntax. You can group results by any selected field or fields, ordering the results in ascending or descending sequence as relevant, and even filter for those group results having certain properties, again, as you might expect from SQL. Let's take a look at some of this over in Couchbase. So over here in my indexes, see that I've created an index to index the type, gender, and address.country code fields. I could open this up over in Workbench to get a better look and notice a few things about this index, including that tick marks have been used consistently across all fields by the UI, even though strictly speaking none of them are necessary because there's no punctuation that would require it here, but it's how the UI works, it's consistent with it. Also, you get to take a look at this with operator that you can explore elsewhere. It's outside the scope of this course, but it allows you to target queries to particular nodes. I'm going to go back into my history here and go to a query that I built for this demo, where I'm selecting the state and counting the state, aliasing that as count, only from user profile documents where the gender is female and the country code is the US. I'm grouping by the state field because I'm also counting that state field, and I want to group count by state. And then I'm ordering the results by state. And it's already executed here, but it's fast, it's indexed, I could run it a few times, and we can see how many user profiles we have in each state within that particular country. We could play around with this a bit. I'm going to go in and in addition to bringing out the state and the count, I want to divide things out further and group results by status. So I will select out the status field, but as you might expect from SQL, if I am going to be selecting that out and I'm using an aggregation function like count, I'm also going to have to group by status. So I'll add status to my group field as well, execute the query, and now I see that I have 16 active users in Alabama, 1 abusive, 2 new, 4 closed, etc. Grouping and breaking out results, again as we keep saying here, as you might expect from structured query language. I could also go in and modify my query a bit further because I want to filter by status as well as group. I'm going to add a having clause because I only want to see my suspended accounts. And I will change the ordering here. Instead of ordering by state, I want to order by the number of suspended accounts, still identified by state, but in descending order, so I see the state with the most suspended accounts first. Execute that query, and I see, I've got 5 suspended accounts in Arizona. Who knows why? Let's also take a look at a different scenario related to the missing operator that we were looking at. Now, I'm going to go over to my documents, and I've got them filtered by country, and I'm going to open my first country document. Now imagine that over the course of the development of my system, I realized I needed to add a new field here. I wanted to track the appropriate language code by country. And I happen to know that the country of Andorra speaks Catalan, and the proper language code for that is CA. So I'll make that change to this document, save that result, then I'll go back to my queries, and I've already got this in my history list. I'm going to bring up a query and run it, where I'm selecting out how many country documents do I have where the language code is missing, because I may have added an additional field or fields into a set of documents, but I need to know, are there other documents that have not yet had this modification made? And yes, I have 257 country documents that have not had a language code added. Of course, I could put the not operator in there, and that pulls out, yes, the one country document where I have added that field. So this gives you just a touch of insight into the way that these operators can be used to monitor the structure of your evolving document set corresponding to an evolving object model. So what have you learned? Well, JSON document structure can be analyzed for whether a field is missing, present but with no value assigned, or present with an explicitly null value assigned. You can also group aggregated results by one or more selected fields, and you can filter aggregate results to those having a particular aggregate value or characteristic. In this lab, we'll walk you through some hands-on work with these techniques and hope you'll find it all interesting enough to solidify your learning with some experiments of your own. But one of the great advantages of JSON as a storage mechanism is the easy capacity to store multidimensional data without getting bogged down by lookup tables. Next up, we'll learn how to query based on values stored in multidimensional structures within your documents. Come on back.